بسم الله الرحمن الرحيم رب زدني علما.
Okay, so now let's move on with understanding the LAN automation process. Like if you just know about the SD-Access or the software-defined access, it's more about the new LAN area architecture. So basically a new LAN architecture, we can say, which is again using the same concept of SDN, the software-defined networking within the physical network devices, but more into the LAN automation. So what is SD-Access? It covers a different range of technologies and the solutions for a LAN automation. So we already know what is LAN, basically interconnecting your devices within the same area. And what we can do is we can also do automation of this LAN, and that is done with the help of this SDA architecture, the software defined access. So it's going to be like a new local area network architecture, which is going to use the SDN concept. And again, we can say like it's a latest technology for your enterprise local area network. So enterprise LAN, and which is going to provide a more efficient way of building your network and as well as managing your network. So the management, operations, and everything you do in a much more efficient way compared to the traditional LANs. Now, again, in this SDA architecture, we will be having a centralized controller. We'll talk about this a little bit more in detail in the later on sections. We call it as a DNA, Cisco DNA Center, or like Digital Network Architecture Center, which is going to be a controller from where we are going to control or manage the complete network. So this is going to provide you the graphical interface, the GUI software. And with the help of this GUI software, we will be providing the network automation by using different APIs and other things. So in the case of SD-Access or SDA architecture, the DNA is going to be the important product in that. Okay, so let's try to get into some more details or what exactly we do here. So most of the concepts are similar to SDN, like some of the key aspects of the LAN automation is zero touch provisioning. Now, the zero touch provisioning is like it's a process where you can allow the networking devices. So all these are networking devices. Now, all these devices can be provisioned as well as configured automatically. So which means you don't need to go to each and every device to do the configurations. You can do it from a centralized controller. So that's what, without any kind of manual intervention. So the SDA solution is going to provide you the zero touch provisioning for all your networking devices within your local network, which means whenever any new device is added to the network. So let's say we are adding some new devices. Now these devices are added to the network. Now these devices will be automatically getting the configurations from the centralized controller. So all the configurations as well as the policy settings. So policy settings refers to what resources they can access, what they cannot access from the DNA, which is going to minimize the manual configurations. So which means there is no need to go to each and every device and do the manual configurations. So this is particularly useful now this is again the common feature in all the SDN concepts. So here with specific to LAN automation, this way you can deploy your network architecture very fast and also minimize the human errors because you're not doing manual. So there is a very less possibility of errors, and as well as it will ensure that all the devices have the consistent configurations. So the zero touch provisioning concept is more about automatic provision of your devices, automatic configuration of your devices without any of the manual configurations like we do in the traditional networks. Now, the other thing is like, again, the dynamic VLAN assignment. Now, dynamic VLAN assignment is more about assigning the VLANs dynamically. Now, if you refer the concept of the VLAN is a method of dividing a virtual network. Basically, we create some virtual networks. So here also the similar concept we have, we call it as a VN, a virtual network, which is going to separate the traffic between any two departments. So separate a virtual network or separate VLAN means there is an isolation of the traffic between them. Again, we'll talk about the VNs concept a little bit more in detail, but let's take the same concept of the VLAN here as well. Now, the normal, if you go back in the traditional way, you need to go to each and every switch. We need to create a VLAN, and then we need to go to the respective ports and assign that particular ports into the VLAN number. So I need to say switch port, mode access, and assign this particular ports into the VLAN. So that is more kind of a manual VLAN configuration, which we do. Now, what is the reason of creating the VLANs? So that we can isolate the traffic between the marketing as well as the sales. So when we configure them in different VLANs, basically we want to isolate the traffic. That is the main reason for creating the VLANs. Now here also, you don't need to go to each and every switch to do the manual configuration. Here also similar kind of thing can be done or automatically done with the help of SDA architecture. So the use case, the sample example, let's say you have a marketing department and you want to make sure that all the users connecting, let's say there is a user 1, user 2, user 3 belongs to the marketing department. I want to make sure that wherever they connect in the network, they must be assigned to the marketing virtual network. And again, there are some separate VM. Let's say we have a guest users, the guest users who visit your company to be able to access the resources. Let's say you got a user 5 and the user 6, the guest users. I need to make sure that these guest users should be able to access only the internet or some other resources. Now, similarly, you have an IP phones in your company network. Now you want to make sure that these IP phones will be assigned to the Vivo IP VLAN. Let's say VLAN 30 or whatever the VLAN. So in this case, you want to make sure that your employee users, let's say marketing, should be assigned to the VLAN 10, and the guest users should be assigned to the VLAN 20, and as well as the IP phone should be assigned to the VLAN 30. So you need to make sure that they will be assigned to the proper VLAN, and that can be done again. And of course, how it is done, we'll see a little bit more in detail, because at the back end, they identify the user accounts, and based on the user account, there will be a specific policy configured. And with the help of that policy, it's going to assign to the particular VLAN or the virtual network. And then it also limits what resources they can access, they should not access. So these all the things comes. But if you compare with a traditional network, in a traditional VLANs concept, we need to do it manually. Now here, you don't need to do it. So based on the identities, based on the users, there will be a dynamic VLAN association can be done. Of course, the concept is slightly different here. Instead of VLANs, we call it as a virtual networks or VNs. We will be discussing more on that a little bit later. Now, the other options, we have a centralized policy-driven automation. Like I said, centralized policy means, again, the same example you can take, like the marketing department. We have a guest user and we have an IP phone. So I want to make sure that these users or these particular department users, whenever they connect, or the devices, now here it can be a user or it can be the device type. Like here, marketing and the guest will be the users, whereas the IP phone comes under the device category. So based on the identity or based on the device type, they should be assigned to the separate virtual network, which we discussed already here. At the same time, you also need to make sure that they will be assigned with some policies. And these policies, you don't need to go to each and every switch and do it. You can do it everything from the centralized controller. Like you can say, like I want to make sure that my marketing employees should be able to access only the marketing resources, let's say marketing servers or marketing data, but they should not have access to any kind of financial data. At the same time, they should not have access to any R&D resources. We have a separate department, let's say research and development, R&D. So they should not access that information. Now, likewise, you have a finance department, let's say another department. This finance department users should be given access to the resources to the finance, but not to the marketing, but not to the R&D, let's say. Now, similar way, again, R&D should have limitations. They should only be able to access the R&D resources. Because just simply assigning the VLANs is not sufficient. You also need to restrict what traffic they can access, what traffic they should not access. So these are something can be done from a centralized policy from the centralized controller. Now, again, what if a user, let's say a marketing user, moves from one building to another building? Now, there is no need to worry, because whenever a device moves from one location to another location, because as the policy is applied based on the identity, not based on the ports. Because in a traditional scenarios, we use ports for identification, but now it is done based on the identity. Identity means the user account or the device type. Now, based on that, irrespective of the location where they are, or even if they are moving from one location to another location, you will have the common policy applied. Because whatever the policy is applied, basically they will remain the same. Okay, so that's something what we call it as centralized policies. So we will be configuring some policies with DNA, or even we integrate with Cisco ICE to do these roles. Now, the other thing, like automated network segmentation. Now, network segmentation, general terminology is segmentation is a way of separating your networks into multiple logical networks, right? So basically, segmentation is like you want the traffic of users. Let's say the company ABC traffic should be separated with the company XYZ or PQR. Or you can say like different departments, marketing, sales, HR should have a logical separation of the networks. So that is done with the help of VMs. So we'll be using some concept of virtual network, VNets, or the VMs, which will be dynamically assigned based on the policies. So which means there is no manual configuration again, as we discussed here, more similar to the dynamic VLAN assignment. So there's no manual VLAN configuration. Without the manual configuration, we can do it. Because if you go back in a traditional method, you need to go to each and every switch and configure the VLANs and then logically separate them. And then if you want to have inter-VLAN routing, you need to configure the router, which will do the inter-VLAN routing. And then you need to apply some ACLs to restrict the traffic from one VLAN to another VLAN. But here you don't need to do that, because once you say that this PC and this PC belongs to the same VM, basically when we say that, which means irrespective of where they are exactly, they can still talk to each other. Whether they are in the same network or different network, we can do that. So we can have a logical virtual network can be built between two different locations or the buildings. We can do that. So again, these all things are automatically generated and applied based on the policies. So there is no need to do the manual configuration. So again, the same example applies. We can use the same marketing users should be accessing only the marketing resources, whereas the guest user should be able to only access the internet. Again, you have an IP phones should be assigned to the IP phone VLAN, or should be only be able to send out or receive the IP phone traffic or the VoIP traffic. Now, there are other things happens here. Even the user device and authentication also happens. Now, user device and authentication is more similar to AAA concepts. If you know, whenever a user connects to the network, whether from the wired or the wireless network, so the first thing it will do is authentication. So it is going to prompt for the login credentials, where you have to enter the username and the password. And based on the username and the password, you will be authenticated. And the same thing here, again, there will be a centralized Cisco ICE, which we'll be using. So again, I'll talk about the different components used. So we'll be using the Cisco ICE servers, external authentication servers to do that authentication part. Okay. So once the user gets authenticated, like the employee users, let's say the user belongs to an employee, he will be assigned to the employee VLAN. Again, after that, there will be authorization process where you need to specify which VLAN or which virtual network they should be belonging to, and what resources they can access, what resources they should not access. So more kind of a policy. Again, we are coming back to the policy where this policy is applied based on the user or the device authentications. Now, why this is there? Because one thing to identify the user, that is the one thing, and the second thing is to prevent any unauthorized users, because you don't want any unauthorized users should be connecting to the network and accessing the resources. So once the authorized user or the authenticated user is connected, then he will be assigned to the specific virtual networks. Like I said, the same example, employees, guest, or even you have some other devices like the IP phones or IP cameras or those devices identified based on the MAC address. Now, again, the role-based access control. Now, this is more on authorization. So if you know the AAA concepts, this is more on authentication. Now, in the case of authentication, it will verify the username and the password and or the device based on the MAC address. It will identify and it will ensure that the right user is connected or the right device is connected. And it is going to check with the help of centralized server, Cisco ICE, it is going to use that. Now, at the same time, it also need to ensure that it is going to authorize like which VLAN or the which virtual network you want this particular user or the device to be connected. Like the marketing department user, then he will be connected to the marketing virtual network. If he belongs to the sales, then it has to be sales. And if it is a HR, then it has to be HR. If it is an IP phone, identified based on the MAC address, it has to be in a separate VLAN. So we need to make sure that it is assigned to the proper virtual network. At the same time, there must be a policy assigned to ensure that what resources they can access, what resources they should not access. Now, again, as I said, the same example, if it is a marketing department, they can access the internal marketing resources, maybe drives, or if he belongs to employees category, he can access internal resources like servers or applications. And if it is a guest user, then he will be able to only access the internet, not the internal resources. If it is a IP phone, then probably assigned to the IP VoIP VLAN and then accessing the VoIP traffic. Now, finally, there is one more thing. There is something called automated monitoring and troubleshooting. Now, we know normally, we know monitoring and troubleshooting. Monitoring is a method where you continuously check the status of your network. You have some statistics, and based on that information, you can, if there is any kind of issues, you can do troubleshooting. So normal monitoring and troubleshooting is something we know, but here we will be doing a more kind of an automated monitoring and troubleshooting is possible, because the SDA network have the capabilities of automated monitoring capabilities, we can say, which can detect any kind of issues, and also it can report any kind of issues in the real time, which is going to support a kind of a proactive troubleshooting. So proactive troubleshooting is something possible. So based on that, whatever it detects and whatever the reports it generates, it can automatically initiate the troubleshooting process without the manual intervention. Like some examples we can take to understand this one is like, let's say there is a network congestion. Assume there is a network congestion in your network. Now the Cisco DNA Center is going to detect that there is a sudden surge in the network traffic, and that is going to lead to the congestion. Now this will result in the large file transfer, because this can impact. This can be typically because of the large files you are transferring, or there might be some kind of video conferencing applications you are running. That can be the reason. So then what it can do is it can generate an alert and send it to the network administrator saying that, okay, this is something what been observed. And accordingly, you can take an action, or you can even configure to take an appropriate action in case if it finds any kind of thing. Like generally, let's say the CPU performance goes something high. So again, that's more kind of a monitoring. But again, we are not getting into that other kind of monitoring. This is more on the LAN automation. Okay. Now, the other things, like even the other example, like you have an endpoint. Let's say this is my endpoint, and this endpoint is going to behave a little bit differently, like it is sending some kind of excessive traffic, which is not a normal. That can be a signs of a malware. Maybe whenever any device gets infected with some kind of malware, it will try to initiate excessive traffic from that PC, which is other than normal. So again, the DNA Center can detect that and generate an alert for that as well. Not only that, even you can take one more example, like in terms of security alerts. We can even say like the system can isolate any kind of suspicious behavior. Means whatever the alert which is being generated, the device can automatically isolate the traffic from preventing any kind of critical impact on the resources. Okay, so there is a way of automated monitoring and troubleshooting can also be done here. So you will have a lot of, in the graphical interface, you will have the options to view the real-time live monitoring. At the same time, you can also do initiate or give actions, some kind of proactive troubleshooting tasks to be done automatically. Okay, so these are some of the benefits, which is more similar to the other things, similar to kind of monitoring, but more specific to the LAN. So it can do continuously monitoring for collecting your data. This can include like the traffic patterns, or it can be the performance of the network or the device status information, or any kind of security issues or vulnerabilities if happens. So it's going to do this in the real time, which means as the network is being monitored, the DNA Center is going to use some different algorithms to collect the information. This can include, like I said, the network congestion or any device fails or any kind of security vulnerabilities or the threats. Additionally, it can generate some alerts. As I said, whenever the issue is detected, the DNA Center can generate the alerts and the notification messages to the administrators. And also it can also take an appropriate action if you configure with some kind of actions to be taken, which is more kind of a proactive troubleshooting. Okay, so these are some of the options, and also it can provide you some data analysis of like historical data analysis as well, and that data can be used to identify, most of the time these network administrators can use this data to understand the reoccurring issues and plan the network improvements as well. Okay, so when we talk about the LAN automation, it's more kind of automating your LAN options, not only just automating your VLANs or automating your policies. Additionally, it will also support means at the back end, there is authentication, there is also authorization involved, and also there are other things like it also supports monitoring and other things. Okay, so as we progress with our topics, we will be seeing all these things with the configurations. But in order to understand, you need to understand, okay, what exactly we do in the LAN automation, what exactly we do in the SDA. This is a kind of an overview of the things what we are going to see in our coming sections.